Alright, today we're going to go over 2 examples for rice tables. So first one, in the reaction the initial concentration of phosphorus pentachloride is 0.400 molar, equilibrium is established in which 0.250 molar chlorine is present, and we want to calculate our equilibrium concentration. So for KEQ, in order to do that calculation, you need equilibrium concentrations. So the key that we're going to need a rice table is that we are given an initial concentration. So R is for reaction, so I'm just going to rewrite my reaction. Alright, I is for the I is for the initial concentration. So I have the initial concentration of my reactant, 0.400 molar. We're always going to assume that the initial concentration of our products is 0 unless it tells you otherwise. So before this reaction begins, I don't have any products yet. Change in concentration. So reactants are always going to decrease in concentration, and I don't know how much it's going to decrease by, so I'm going to put an X there. Remember, for this step we want to bring down our coefficients. So in this case, based on my balanced reaction, my coefficient is 1, so this would just be minus 1x. And again, it's minus x because reactants decrease in concentration. The products are going to increase in concentration. And again, they both have a coefficient of 1. For the equilibrium row, we're just going to add together initial and change. So to get my equilibrium concentration, I'm going to take my initial concentration minus the change in concentration. 0 plus x is x, and for chlorine, 0 plus x is x. So once you have your rice table filled out, our next step is we want to solve for x. So the other thing the problem tells us is that at equilibrium, the concentration of chlorine is 0.250. Well, I also know at equilibrium, chlorine is going to be equal to x. So that means 0.250 has to equal x. So now we need to solve for the equilibrium concentration of phosphorus pentachloride and phosphorus trichloride. So all that I'm going to do is look at this equilibrium row. So at equilibrium, the concentration of phosphorus trichloride is going to equal x, and x is 0.250 molar. For phosphorus pentachloride, at equilibrium, my concentration would be 0.400 minus x, or 0.400 minus 0.250. So its concentration would be 0.150 molar. Alright, next problem. Again, I see initial concentration, so that's going to be my key that I need a rice table. So again, R is for reaction. I is the initial concentration. So the initial concentration of hydrogen iodide gas is 0.350 molar. And again, unless it says otherwise, we're always going to assume that the initial concentration of our products is 0. Reactants are going to decrease in concentration, and we want to pull down that coefficient. So for my hydrogen iodide gas, it would be minus 2x. The negative sign, minus sign, because it's decreasing in concentration, and the 2 is because it has a coefficient of 2 in the balanced reaction. Products always increase in temperature, so they're always going to get a plus sign. Both my products have a coefficient of 1, so they're going to be plus 1x. For the equilibrium row, I'm going to add together initial and change. So 0.350 minus 2x. 0 plus x is x, 0 plus x is x. Alright, once you have the rice table filled out, next step is to solve for x. So the problem tells us at equilibrium, the concentration of hydrogen is 0.115 molar. Well, I also know that at equilibrium, hydrogen is going to be equal to x. So that means x is 0.115. I can now solve for the concentration of iodine, which is going to be equal to x, and x is 0.115 molar. And then hydrogen iodide gas is equal to 0.35 minus 2 times x. So let me grab a calculator really quick. .120 molar. So this question is asking for the equilibrium concentration of hydrogen iodide gas. We just calculated that at 0.120 molar. But we also have to calculate Kc, our equilibrium constant. So to do that, first we need to write an equilibrium expression. So we're going to do products over reactants, each raised to the power equal to their coefficient. So hydrogen iodide gas gets squared because it has a coefficient of 2. Remember, if you have more than one product or reactant, you multiply them together. So now I just need to plug in my equilibrium concentrations. Remember, there are no units for our equilibrium constant, so Kc is equal to 0.918. Hope that helps. Email me with any questions. Don't forget to complete the Google form and work on your Mastering Chemistry.